Hello everyone, welcome to this new playlist of top 150 interview problems on LeetCode. So I'll be making videos on these 150 problems in series as I'll keep on solving these questions and after or if I will not be able to solve any problem, then I'll first solve it and do the dry run and understand the solution. Then I will make the video. So this is for my practice, but I'm recording this and putting it on YouTube so that if anyone like me who is preparing for interviews can come upon these videos and they can watch the solutions and the approaches and the how they can do dry runs. So let's go with this particular problem. It is the first problem on this list, that is merge sorted array. So it's an easy problem. You can see the tag. It's the first problem, so it should be easy to just give you a little bit boost, but it's not that much easy. Let's go through the problem statement. So you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. So we have two sorted arrays, nums1 and nums2, and the length of nums1 is m, and the length of it's not length, sorry. So m are the number of elements in nums1 and n are the number of elements in nums2. Fine. So now we have to merge nums1 and nums2 into a single array sorted in non-decreasing order. So our task is that we have to merge these given arrays and they should be sorted. As these nums1 and nums2 are sorted, so the final array should also be sorted. Okay. So the final sorted array should not be returned by the function. So we don't have to return the final sorted array. We can see in this function also the return type is void. So we have to then to accommodate this, nums1 has a length of m plus n. So our this nums1 array is already long enough to hold all the elements of nums1 and nums2. So its length is already m plus n, where the first 10 elements denote the elements that should be merged and the last 10 elements are set to 0 and should be ignored. Nums2 has a length of n. So we can see this example. Nums1 is 123,000 and number of elements are 3, m equals 3, but the last three places are set to 0. So these places, these empty place is given for the elements of nums2 array. So nums2 array is has also got elements, three elements, that is 2, 5, and 6. So we need to somehow transfer these elements of nums2 into the nums1, and the resultant, the finally the nums1 should look sorted. That is, it is like this, that in the non-decreasing order. It means we are moving from left to right, the elements are increasing. uh, okay, so this is the problem, we have understood it. Now I'll be we can solve it. There is an inefficient way to solve this problem, and there is an efficient way to solve this problem. The inefficient one, I'll be just verbally telling the approach, not implementing it, because I don't want to waste a lot of time on an inefficient solution. So you can, what you can do, you can take you can create one array of length m plus n, and first you push the elements of nums1 into that, then you push the elements of nums2 into that, and finally you can apply arrays.sort method, and your final array will be sorted, and then you can return it. So it's not a very efficient solution, uh, if we see in both terms, in the terms of space and in the terms of time. So now let's talk about the efficient approach. So the efficient approach is will be like this. So I'll be comparing the last element of both the arrays. And I know if the last element, the max of the last element should be present at the end of the final array, because we know the elements are already in sorted order, and the final answer will also be in sorted order. So I'll keep on comparing from the last. I'll compare 3, I'll compare 6. I know 6 is uh, bigger, so 6 will come in the last. Okay. So now I will move my pointer from 6 to the 5. Then I'll compare 5 and 2. The 5 is bigger, so I will push at the next place. I will push 5. I will put 5, right? And then I'll keep on doing until both the arrays are finished, and finally I will get my output. So quickly, I'll be quickly coding this approach uh, here, and then I will finally show you the dry run of this example, so the things will be clear. Okay, so let's quickly code it out. I will take one pointer I, that will be m minus 1, and I'll take one more pointer j, that will be n minus 1, or let's give them some good names. I and j are so casual. Let's say for nums1 I'll be using I, so I'll give it name as left, and for nums2 I'll be using the name right. Okay, fine. Then I'll be taking one more pointer position, and this will be m plus n minus 1. So this pointer will keep the track of the position where I'll be uh, putting the element in the nums1 array, right? Okay, so now I will run a while loop, and this while loop will run till I have elements in both the arrays. So when left is greater equal 0, and when right is greater, greater equal 0. So why I'm putting this end condition here? Because suppose in some case my left pointer has reached to 0, and then in the next iteration my left pointer will become negative, and I'll be then comparing the element of left pointer negative index, as negative index doesn't exist, so it will give me an exception. So I'll make sure that my both the pointers should uh, be in the limit till 0. That's why I'm using this end condition. So at any point when this condition will not match, this while loop will break, and we will move towards the next part. So now let's go inside this while loop. Now what I'll be doing inside this loop, I will do comparisons as I told you. So I'll compare if nums1 nums1 of left, because left will be the pointer I'll be using for the nums1 array, is greater than nums2 of uh, nums2 of right, then what I will do, then I will set the nums1, because nums1 will be the final array I'll be returning, nums1's position to nums1 left. Fine. So the position is initially is m plus n minus 1. That is, you can see it is the last position. This I'll start setting from the last position. Fine. So this is my uh, this if condition is done. Now I need to make sure that I have done with this left index. Then so I need to decrement it. So left minus minus. Fine. And now if this is not the case, then the otherwise case will be in else. I'll be setting then nums one of uh, position to nums 2 of right. All right. This is it. And here I'll be decrementing the right pointer because I'm done with this pointer. Okay. So I'm done with comparisons. Now finally to work this thing, I need to decrement position also because I'm done with filling this position also. Fine. Now, in some cases, I will have some elements left in this nums2. Fine, because finally I'll be returning nums1, so I'll be done with this loop uh, for the nums1. But for nums2, some elements might be left. So to make sure that I have put all the elements, I will run one more loop where my right will be greater equals 0. And in this case, I'll be doing the same operation, nothing extra. So I'll be copy pasting it. A bit of formatting and done. So this is the entire code and it will take care internally. It will return the nums1 array. Okay. So let's try to run this, whether this is working or not. I need to do one more thing here. I'm not decrementing position. So somewhere it will give me an error. Now it is fine. Now let's try to run this. I think it should work and it has got accepted. Now let's try to submit this and it has got accepted. Fine. So the time complexity for this approach is big O of m plus n because we are iterating on on these two arrays, nums1 and nums2. So in both the cases, we have to iterate on the entire length of these two arrays. So the time complexity will be big O of m plus n. We can say that the time complexity is linear in this case, and that's a fast solution. We can see it is beating 100% of users with Java. Fine. So now this thing is done. Now let me show you the dry run as I promised. Okay. So let's do one thing. Let's hide this thing and let's make this side by side because I made one explanation image. Okay. And I don't need this. I need only the code. Okay. I think now it is visible. Fine. So I have taken that test case from the example. Nums1 is 256,000 and nums2 is 123. So in the first iteration, here my I is left and J is right and T is position. Fine, because I've made some meaningful names here in the code, but for the dry run, I have taken I, T, and J. So in the first iteration, it will be comparing 6 and 3. Fine. So the 6 is bigger here. So 6 is bigger. I'll take a pen. So I'll keep marking on it that where I'm doing what. Fine. Right. So this 6 is bigger than 3. 6 is bigger than 3, so I'll be setting 6 at this position, at this position. So you can see in the next iteration, you can see the nums1 has become 256006. And I've decremented t, that is position, to 4, and I have decremented the left, that is I, to 1, and right, my right is as it is. Now I'll be comparing 3 with 5. So in this case also, this 5 is bigger. So I'll be setting this 5 to t equals 4 position. You can see I've set it here. In the next iteration, you will find it. The 5 is set here. And I'll decrement the I to 0. So nums1 will become 256056, and nums2 will remain as it is. And now t has become from 4 to 3, and I has become 0. Fine. Now I'll compare 2, that is I0 to the J2, 3. So now 3 is bigger. So 3 is bigger, so I'll be setting 3 at t equals 3. So I have set 3 at t equals to 3, and I've decremented J to 1, and my I will remain the same because this has not touched. Okay. So in the next iteration, I'll be comparing now 2 with 2. So as I have used this condition here, my nums1 left should greater than nums2 right. So it is not greater, it is smaller. So my this 2 will get set here, and my j will be decremented because my this if condition will not work, although this 2 is equal to 2. So it is not true for equal values. It is only true for greater values. So my else case will run, and my else case will run. That's why I'm decrementing j here, and I'm setting this 2, not this 2. I'm setting this 2 to t equals 2. You can see I've set it here. Now I'll be comparing I equal 0 and j equal 0. So now I0 is clear enough because it's a 2. So now I'll be setting 2 at t equals 1. You can see here. Now it is set here 2. So now finally it will become 2, 2, 6, 3, 5, 6. And this I will become minus 1 here. So this is the case I was talking about, that at some place my pointer will become negative, and in that case I need to do something extra. So my this element has now uh, left, and I am done with this loop 1. Now I have to move towards the loop. So in loop 2, I'll be checking with I'll be checking only j, that is right. So if my right is greater equal 0, nums1 position equals nums2 right. So position is 0 and only one element is left. So 1 will be set to this position. So finally my array will become 1 and comma 2 comma 2 comma 6 comma 3 comma 5 comma 6. Oh gosh, look at the writing. So finally, my array will be looking like this. Nums1 will be looking like this. And this is sorted. We can see 1, 2, 2, 6, 3, 5, 6. So it is a sorted. So initially, the given arrays, that is 2, 5, 6, and 1, 2, 3 were separate two arrays. Now they have got merged into single array, nums1, and that too, they are sorted. So I think you have understood this, Dwyer. Uh, so this is it for this problem. I hope you have understood this. If you like this video, please share with your friends and subscribe to the channel, and keep watching this playlist. And if you are also preparing for tech interviews, then you can solve along. You can also be the part of preparation journey so that you can also crack some good interviews. And I hope you, I'll wish you all the luck. And I hope you also got success in your future interviews. So that's it for this video, and I'll be meeting you in the next one. Till then, keep enjoying, keep learning, and keep growing. Thank you so much for watching this video. Bye bye.